Okay, let's finish off section 2.7, inverse functions. And this video will pick up with example 4. Find the inverse of this function. Okay, we do have our 4 steps. Step 1, replace the f of x with y. So now it's y equals 5 divided by x, that plus 4. Step 2, swap the variables. So I'm going to replace the y with an x, and I'm going to replace the x with a y. Now let's see, we want to solve for y. We want to get y by itself. Probably the easiest way to go about this right here would be to multiply and clear both sides of fractions. Well, the only fraction we have is right here, 5 over y. And how do we clear that denominator? Well, we multiply by the denominator. I'm going to multiply both sides times y. So here on the left is going to be x times y equals, well, here's 5 over y times y over 1. So we're going to get 5y over y, and the y's cancel, leaving the 5, plus, and don't forget to distribute the y to the 4y. All right, again, we're trying to solve for y. So let's get all factors or all terms with a y on one side. I'm going to get them all on the left, so I'm going to subtract this one out. Xy minus 4y equals 5. Okay, now on the left I see 2 terms, each have a factor of y. So let's factor it out. Factor out the y, and we're left with, in the parentheses, x minus 4. And that's all equal to 5. Okay, last step, divide by that quantity, x minus 4. So I divide out this x minus 4. I divide the other side, 5, by the quantity x minus 4. And I replace the y with f inverse. The inverse function of our original is 5 divided by the quantity x minus 4. All right, you've heard of the vertical line test. The vertical line test tells us, do we have a function? The horizontal line test will tell us if our function is 1-to-1 and therefore has an inverse. So let's see what happens if we try to find the inverse of the standard quadratic function, f of x equals x squared. Step 1, replace f of x with y. So y equals x squared. Interchange the variables. So now it's x equals y squared. And we want to solve for y. So to get rid of the square, we square root both sides, and we wind up with y equals plus and minus the square root of x. This right here, I say, is the dead giveaway. That means we can plug in a number for x. For example, let's say we plug in 4. And if we take the square root of 4, we get 2. And that means we have a positive answer 2. And we also have a negative 2 as an answer. So 1 input makes 2 output. 1 input. And that leads us to 2 outputs, or 2 answers, 2 different answers. And that right there is our disqualifier that this is not a function. Not a function. And let's think about it graphically. Y equals x squared, that's our standard parabola. Let me get a line here. So here's our vertical line for the vertical line test, and the parabola easily passes the vertical line test. The parabola is a function. But if we turn the vertical line horizontal, we're going to hit the function at 2 spots, and that will tell us that our inverse is not going to be a function. Remember, one way to think about an inverse is we switch all the x and y coordinates. It's like spinning the graph 90 degrees. So now I can look at this and say, okay, does this function pass the horizontal line or the vertical line test? No, it does not. So this inverted function is not a function. It did not pass the test. So a function f has an inverse that is a function f inverse if there's no horizontal line that intersects the graph at more than one point. Which of these following graphs have an inverse? Well, obviously letter A, a straight line. Yes, we have an inverse. Downward opening parabola. No, it is a function, but it does not have an inverse. We can see here on this line graph with some curves, we're going to hit at several spots at least. So that's going to also be no inverse there. This looks like a basic cubic function, and any horizontal line will only hit it once. So yes, this one is going to have an inverse function. All right, a function that passes the horizontal line test when no two different ordered pairs have the same second component. This means that if x1 does not equal x2, then f of x1 does not equal f of x2. Such a function is called one-to-one. Thus, a one-to-one function is a function with no two different ordered pairs that have the same second component. Only one-to-one functions have inverse functions. Any function that passes the horizontal line test is one-to-one. Any one-to-one function that has a graph, that will pass the horizontal line test. And there is a relationship between the graph of a one-to-one function f and its inverse, f inverse. Because inverse functions have ordered pairs with the coordinates interchanged, if the point AB is on the graph of the function f, then the point BA is on the graph of f inverse. The points AB and BA are symmetric with respect to the line y equals x. Thus, the graph of f inverse is a reflection of the graph of f across the line y equals f. And that's illustrated in this picture here. The line y equals x, that means all the ordered pairs are the same. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on. It's running diagonally through the first quadrant of the Cartesian plane. Here's the point A comma B. Reflected over that line will be B comma A. And that's going to help us here in example 6. Use the graph of the function f to draw the graph of its inverse. I wish, no, this doesn't have the dotted line option, but maybe I can do this. I'm going to do a very thin red line here, cornering through the graph paper. That's the line y equals x. So the inverse, I'll just reflect this these line segments across that line y equals x. Or you could think about it as reflecting points. Let's see here. This point is -3, -2. And I'll do these in blue. This point here, -1, 0. This point here is 4, 2. If I reverse those coordinates, I'll have points on the inverse. So let's see, I'll reverse this point, -2, -3. That's on my inverse function. If I reverse -1, 0, I get 0, -1 right here. And 4, 2 reversed is 2, 4. If I connect those dots, I'll have the graph of my inverse function. And there we go. And you can see they are reflections across this line y equals x. We have those 2 points lining up. 2 more here. And finally these 2. Final example. Find the inverse of a domain-restricted function. So find the inverse of this function for all x's greater than 0, and then graph the function and its inverse on the same rectangular coordinate system. Okay, here's our original function. F of x is x squared minus 1. And we're only going to graph that for x's greater than 0. So this is the standard parabola x squared shifted down 1 unit. So we're going to start here, and then we'll have this point on our graph, and then here, and here. So if I connect those dots, I don't like that one very much. It needs a little more curve here at the bottom. Okay, good enough. Let's find its inverse. So step 1, replace f of x with y. Step 2, swap the variables. Step 3, solve for y. So I'm going to add 1 to both sides and square root. Y equals, so I add 1 to both sides and square root. And again, we are domain restricted. X's are only the positive ones there here. So do we need the plus minus? No, we're only going to be worried about the positive answers. So, and we replace the y with f inverse. And that's the square root of x squared plus 1. Back to the graph. This is f of x. So let's graph f inverse. Well, we have our basic square root function. The square root function, that basic square root function starts here and sort of goes out this way. But we were shifted, this plus 1 under the radical means we're shifted 1 unit to the left. Oh, and back that up, I messed up my function here. When I was solving this for y, I don't know how I got that x squared under there. So it's going to be x plus 1, and then we square root both sides. So there we go. There's our f inverse of x. That just didn't look right. Square root of x plus 1. So let's go back here. Again, our basic square root function looks like this, but the plus 1 moved us 1 unit to the left. So we're going to be here, and here, and here, and here. And if I connect the dots, and if I put my diagonal line through here, there it is. We can see the points that I plotted lie reflected across that line. So these 2 points straight across, as are these and these 2 also. And let's see, did that answer everything? Find the inverse. We did. Graph them both. We did. All right. Time for you to try some here. Checkpoint 4, 5, 6, and 7. All right, pause the video and try those and then check your answers. Okay, checkpoint 4, step 1, replace the f of x with y equals. Step 2, swap the variables, x equals 3 over y minus 1. Okay, I want to solve for y, so I want to clear all denominators. I'm going to distribute a y. Y times x is xy equals y over 1 times 3 over y is just 3. And then distribute the y to the minus 1 is minus y. Okay, get all the y's on the left. Xy plus y equals 3. And let's factor out a y. Y times the quantity, x plus 1, is equal to 3. And divide both sides by the quantity, x plus 1. Replace y with f inverse of x, and that's equal to 3 over the quantity x plus 1. And that should be our final answer. Okay, down below, A, B, and C. Do the graphs represent functions that have an inverse? Well, here we're going to fail. Did not pass the horizontal line test. Here looks like a basic log function. Yes, that will pass the horizontal line test. And here's a basic exponential. That will also pass the horizontal line test. All right, let's see what we got here. The graph of function f consists of these line segments, one from the point -2, -2 to the point -1, 0, and the second goes from that point to the point 1, 2. And let's see here, I will connect those dots. Oh, I need a thicker line than that. All right. Now it says graph f, and then use this to graph its inverse. So here's f of x, and I'll switch over to blue for its inverse. Well, we can flip-flop the points to find points on the inverse. Well, this -2, -2 is going to stay the same. -1, 0 gets switched to 0, -1. And then we're going to pick up at that point and then go to 2, 1. So my first blue point is right on top of this red one. And then 0, -1 will be right about here. And 2, 1 right here. And we'll do some blue segments there. So that, whoa, there we go. That is our inverse, f inverse of x. And remember, it'll go diagonally through, or kitty corner through the line y equals x. So we are symmetric about that green diagonal line right there. Okay, checkpoint 7. Find the inverse of this and graph them both on the same coordinate axes. Well, our first one, f of x is x squared plus 1. That's our standard parabola, moved up 1 unit. So we're going to look something like this. Oh, that's not very good. That's a little better. All right, let's find its inverse. Step 1. Step 2. Step 3. Okay, the square root function, the minus 1 means it's a shift to the plus side 1 unit. So we're going to start here and plot a few more points. There's our inverse. Again, we are reflected about the line y equals x. Again, here's the point 2 comma 5. Here's the point 5 comma 2. 2 1 and 1 2. 1 0 and 0 1. Beautiful. All right. Some homework problems. Give those a try tonight.